Okay, so taking a look at the next section, we want to talk about what we mean by a periodic function. So jump ahead, what a periodic function is, it's something like this. It's like the sine wave on the graph or the cosine wave. A periodic function has y values that repeat at regular intervals. So we go up, we go down, we go up, and then we repeat. Up, down, repeat, up, down, up, repeat, forever and ever. One complete pattern of a periodic function is called a cycle, and the horizontal length of one cycle is the period. So in this case, we go up, down, up, or sorry, up, down, what am I saying? Up, down, up. There we go. And we get back to where we started. Now that happens in 2 pi, after 2 pi for our x-axis, right? So here they got the number 6 point something, so that's 6.28. Here, once you actually go there, you see that's 2 pi is the exact value. So that is the period of this periodic function. That's how much angle needs to be processed before you get through the whole thing. Now, a lot of times we'll talk about like time periods, and if we knew something about like how something is turning, for example, like if we're talking about like a Ferris wheel that's going around, we could talk about like how many seconds does it take to go all the way around, and that would be its period. It would be an amount of seconds. But you could also talk about what kind of angle has to go by before you get all the way around. And in that case, thinking about the angle, then the period is 2 pi radians, or 360 degrees. Okay, every 360 degrees or every 2 pi radians, you have completed one rotation, you're back to where you started, and you start again. The values of the sine and cosine functions can be found by using the unit circle. As you move around the unit circle, the values of these functions repeat every 360 degrees or 2 pi radians. So the sine and cosine functions are periodic functions where sine is x plus 2 pi. Where the sine of x plus 2 pi equals the sine of x. So they're saying that if you've got some angle and you do a full rotation of 2 pi, well, you're back where you started. So you should have the same sign. So what they're saying, like if we did pi over 4, let's do pi over 3. The sine of pi over 3 is 0.866. It's that y coordinate, the length of the green line below it. And the sine of 2 pi plus pi over 3, well, it's going to be the same thing. Because if I add 2 pi to this position, I go all the way around the circle. If I added 2 pi to this position, I'd go all the way around the circle. Okay, so that's what they mean here when they say x plus 2 pi is the same as just sine of x. Same thing here, the cosine of x plus 2 pi is just the same as the cosine of x, because it's repeating every 2 pi angles that travel by. Because tangent, cosecant, secant, and cotangent can be defined in terms of sine and cosine, they're also going to be periodic functions. Recall that the values of sine of theta and cosine of theta are the y and x coordinates, respectively, of the point P, xy, where the terminal side of an angle theta intersects the unit circle. Thus, you can use the values of sine theta and cosine theta shown on the unit circle to graph the sine and cosine functions, where the x-axis represents the value of theta and the y-axis represents the values of sine or cosine theta. Okay, so if we're just looking at the sine graph, what they're saying is that the x-axis is representing the angle. Okay, so we can see the angle here is 0, pi over 6, pi over 4, pi over 3, pi over 2. They're not listing all of, well, they are. 0, pi over 6, pi over 4, pi over 3, pi over 2. They just don't put it on the axis. So I'll just count 0, pi over 2, pi, 3 pi over 2, 2 pi. So that's 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are the quadrantal angles that they've put on here. 1, 2, 3, 4 of them. Okay. Now, what the y-axis is measuring, for this, it's measuring the value of the sine of that angle. So we would only be looking at the y-coordinate. So the y-coordinate goes 1, 0, -1, 0. Okay, and here we're up at 1, and then we're at 0, and then we're at -1, and then we're at 0. So the height of these ones, like here it says 1/2, So we have 1/2, and then let's think about what our next two heights would be. Well, it would be the y-axis. So it'd be 1/2, then the next height would be square root of 2 over 2, and the next height would be square root of 3 over 2. Okay, so that is what the sine function shows us. It shows us the value of the sine of the angle as that angle increases. Same exact thing for cosine. So the only difference between these two things, sine of x and cosine of x, when we look at their functions, is that sine of x starts at 0 and goes up to 1. Cosine starts as 1 and goes down to 0. They're the same exact thing. They're just kind of, one of them's been slid over to the side. In fact, if I was to say this one minus pi, maybe it's pi over 2. I'm trying to get them to overlap. Intuition's off. Okay, plus pi over 2. There we go. So they're just out of sync by pi over 2. So that'd be 90 degrees. They're out of sync by quarter of a rotation. We call that orthogonal when things are 90 degrees to each other. Okay, each point on the graph, y equals sine of x, is given by x comma sine of x. So each point on this graph, the x location, so like let's talk about this point right here, the x location on this graph is the angle. It's that angle of pi over 2. And the y location is the sine of that angle. Okay, so that's kind of the gist that we want to get from this, is that this line here on the graph is keeping track of the sine of the angle as the output, that's the height of the line, where the input is the angle itself. Using the unit circle, x is the measure of the angle, and sine of x is the y coordinate of the corresponding point on that unit circle, right? That's where we were traveling around looking at the y values. So if we just looked at all these y values, okay, all the right-hand values on all of these coordinates, those are the values in order as they go up and down on that graph. Okay, same thing for cosine, just that cosine starts at 1, right? And if you think about your interactive unit circle here, if we start over here, well, the cosine is the length of the blue line. So it starts at 1, then shrinks down to 0, goes to -1, goes back to 0, and then back to, goes to -1 and then back to 0. And we see that on the sine graph here. We see, I'm mixing them up. We see that on the cosine graph here. So we see it starting at 1, going to 0, going to -1, back to 0, and then back to 1. Okay, and that is it for getting started on understanding these trigonometric functions and their graphs.